I'm your man, John Wilson. Today we're starting Unit 5, Module 11, Angle Relationships and Parallel Lines, and even some triangles. But before we even get started, we have to go and figure out what it is we're talking about. Now today we will understand the relationships between the angles that are formed when parallel lines, we know what parallel lines are? Yeah. Parallel lines are cut by a transversal. Additionally, we will detail the algebraic method used to determine angles given set parameters. Which means that if we're missing an angle here or there, I'm going to teach you guys how to go and find it using just a little bit of algebra and all the stuff you know about parallel lines and transversals. Yes? I'm going to show you what that is in 1 second. A transversal is a very special type of line that cuts two parallel lines and creates a whole variety of different angles. And the truth is, given two parallel lines and two transversals, I could also again prove to you that a triangle is 180 degrees. We'll get there maybe next time. But right now though, let's talk about the most important shape that you can know for this module. Most of this is visual, so pay attention. I said visual, so you pay attention. Alright, so we're going to start with a very simple shape here. Now, if you pay attention to this, all the geometry for the rest of your life should start falling into place for you, because you're going to realize we start coming back to the same numbers over and over and over again. This is a what? Circle. It's a circle. And a circle is how many degrees? 360. 360 degrees. We agree on that. A circle is 360 degrees. There's a mathematical formula to prove that to you. Right now, rather than proving it to you, I just want you to understand that it is 360 degrees. I'll prove it to you later on. So we know it's 360. Now, if I were to take this circle and I were to put a straight line through it, let's see what would happen. Right through the middle of the circle, right about there. Is that through the middle? It's hard to see it here. A little up? Right there? Yeah. Right about there. Okay, so I cut the circle in half. Now this line right here is known as a straight line or a straight angle. Anybody know how many degrees a straight angle is? 180 degrees. And that also makes sense because if we cut a circle in half, each half is going to be how many degrees? How many? 180 degrees. Less drawing, more just paying attention up here. You can always go back and draw on later. Okay, so we took our circle, we cut it in half. We have two halves that are 180 degrees. We also have a straight line, and this straight line is 180 degrees. Now, if I were to take another line here, and I were to cut this circle into quarters, kind of looks like that scope that you guys use on Modern Warfare or whatever it is. Something like that, or a little sniper scope for you. All right, now I've created 4 quarters of this circle. And each quarter is going to be how many degrees? 90 degrees. Let's see. Look, angles are created here. That's a 90 right angle. 90 degree right angle, 90 degree right angle, 90 degree right angle, 90 degree right angle. And all that, 90 times 90 plus 90 plus 90 plus 90 equals 360. It all goes back together. Now what I'm going to do is I'm going to take this, and I'm going to tilt it just a little bit, and I'm going to get rid of our old friend, the circle. And let's just drop him down a little bit. And then we're going to put another line through it, and you are going to tell me, when I have two straight lines that never get closer together and never get farther apart, those are known as parallel lines. So these are, right here, parallel lines. And this right here, I believe somebody asked us a second ago, this line that cuts through them is a transversal. And this transversal, don't worry, all this will be on the next couple slides in your notes. If you don't feel like writing it now and just paying attention, it will all be in there. This is a transversal. And when this transversal cuts through those parallel lines, it creates 8 different angles. 1, 2, 3, 4, 5, 6, 7, 8. Now I say different, but in fact, they're very similar to each other. I want you guys to look at just this angle right here. Can anybody tell me what type of angle that is? It's an acute angle. It's 45. Well, it's not 45 really. Acute just means that it's less than 90 degrees but greater than 45. No, greater than 0. Greater than 0 but less than 90. That's an acute angle. So we have an acute angle here. I have an acute angle here. I have an acute angle here, and I have an acute angle here. All right. Let's keep going. Can anybody tell me what type of angle this is? Obtuse angle. And if that's an obtuse angle, that means that this angle here is a obtuse, 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 and obtuse. So when I cut those parallel lines with a transversal, I created 4 congruent, what's that word mean, congruent?
Same.
It's the same. 4 congruent acute angles, 4 congruent obtuse angles. But hey, look, her old friend, Mr. Circle, isn't actually just hanging out there in disguise. If we put all these together, isn't that just a circle?
Yes.
Yeah.
And all 4 of these should add up, let me just change that a little bit, to equal how many degrees?
360.
360. Oh, it all comes back. Now, if I were just to take these 2, that's half a circle, what do they have to equal up to? 180. What about, I'll use a different color because it starts to become hard to see the more lines I put. What about those 2? What should they equal? It's still 180, it's half a circle. What about these 2? What should they equal? 180. You see how all these things start flowing together? And then last but not least, if I were to look at these 2, what should they equal? 180. It's just a series of circles and half circles and straight lines. This is honestly one of the easiest concepts to master because you notice we kept coming back to some of the same numbers. 360, 180, and even if you forget about your old friend, oh, I need you to stay. I need you to go. Where are you? Okay, I need you to go. Even if you forget about the circle, you realize that this is still, if you were to put these together, what type of angle is that red line? It's a straight angle, and a straight angle has to equal 180. So if I were to tell you that this was 100 degrees, what's the only thing that this can be? 80 degrees, because together they're a straight angle, they're also half a circle, which is 180 degrees. Lots of different ways for you guys to figure out what the missing angle measure is. Let's actually go in and see what happens in detail and what all those different angles are called, because they all have names. Whether they're alternate interior, alternate exterior, corresponding, vertical, whatever, they all have names, and I want you to learn them all, because it's not so much that you know what the degree of the angle is, you have to know the relationship behind it. Yes?
Will there be more than one transversal in one of these?
Oh, well, there could be more than one transversal, because if I go back here for 1 second, we could always add in another transversal, and what you're going to see is, if I add in another transversal, hey, what type of shape did I just create? A triangle. And this is where you start to realize another way, which we'll know at the very end of this, why a triangle is 180 degrees. So, we're going to move on to the next slide here, and we're going to go and we're going to define all of this information. Now, who remembers? We just said it a second ago. What's this line called? Transversal. A transversal. A transversal is a line that intersects 2 lines in the same plane at 2 different points. When this happens, 8 angles are formed. Remember, we have 4 acute angles and 4 obtuse angles. But if we dig deeper, we see that there's even more names for these angles. And there's more ways to help us identify what missing angle measures are. Now, before we even get to the next slide, if we're outside, so these are the parallel lines. We're going to say that this is inside the parallel lines. This is in, and these is out. If we're outside the parallel lines, what's another name for outside? If I say that you're outside the classroom, I can say that you are on, starts with an E. Anybody? Exterior. These are angles created outside of the parallel lines are known as exterior angles. There's exterior, 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 and exterior. Those are the 4 exterior angles. Obviously, if I have an exterior, I must also have interior. And on the inside of the parallel lines, 1, 2, 3, 4 interior angles are created. And if you add up corresponding interior and exterior angles, all 4 of these angles together should equal 360 degrees. And if I were just to add these 2 together, what do you think they would equal? 180 degrees. All right, does everyone have this written? We're going to go into a little more detail here and talk about what specific angles are for. Everyone have this? Yes, 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 no, maybe, kind of, sort of. Okay, so first type of angles we want to talk about are alternate exterior angles. Now, exterior means obviously that they are what? Inside or outside of the parallel lines? Outside. Who knows knows what the word alternate means? What does that mean?
Different?
Well, different, yeah, kind of. Opposite, kind of opposite. Now, the question is, well, opposite to what? We're talking about alternate exterior. Alternate exterior angles are on opposite sides of the transversal. They are on the exterior of the parallel lines. And most important, to help us find missing angle measures, they are, anybody knows what goes here? Starts with a C. Congruent. Alternate exterior angles are congruent. And they must satisfy all that criteria. They must be on opposite sides of the transversal, they must be outside of the parallel lines, and they must be congruent. If it doesn't meet all three criteria, then you do not have alternate exterior angles, you probably have something else. Let me show you how we identify alternate exterior angles. So, alternate exterior, 3, 4, 5, or 6. Are those going to be exterior, yes or no? No. 3, 4, 5, or 6. No, I'm only dealing with 1, 2, 7, and 8. So I'm going to start with angle 1. And I want to find the alternate exterior angle to 1. Now, first things first, must lie on the opposite side of the transversal. Is 7 on the opposite side of the transversal? No. No, it's on the opposite side of the parallel lines, but that's the transversal, which means it could not be 7. Okay, that leaves me with angle 2 and angle 8. Next thing, they must be on the exterior of the parallel lines. Well, aren't these both on the exterior? Yes. So that doesn't help. But the very last thing is they must be congruent. What type of angle is angle 1? Acute. What type of angle is angle 2? Obtuse. Can those ever be congruent? No, because remember, acute is less than 90, obtuse is more than 90. So it can't be 2. That only leaves us with angle 8. And we see once again if it meets all the criteria. All right, opposite sides of the transversal, yes or no? Yes. Outside of the parallel lines? Yes. Are they congruent? Yes, because this acute angle and this acute angle, whatever the measure of 1 is, the measure of 8 will be the exact same thing. So that's going to be our first set of alternate exterior angles, angle 1 and angle 8. Shimon, can you give me the other set of alternate exterior angles there? 2 and 7, perfect. 2 and 7, does it meet the criteria? Well, they're both obtuse, opposite sides of the transversal, outside of the parallel lines, 2 and 7. So if you know the measure of 1, you know the measure of 8. If you know the measure of 2, you know the measure of 7. Now, if we have alternate exterior, that means that we must have alternate interior. Alternate interior angles lie on opposite sides of the transversal, inside the parallel lines, and once again, they are congruent. The only difference between these two types of angles is that one of them is on the outside of the parallel lines, one of them is on the inside. Other than that, they're very similar. All the other criteria is the same. Corey, can you give me a set of alternate interior angles? Remember, we only have 3, 4, 5, and 6 to work with. Everything else is outside. So, what do you got? 3 and 6. Let's see if it meets the criteria. Alternate sides of the transversal. Yes. Inside the parallel lines. Yes. Are they congruent? That's an obtuse angle. That's a obtuse angle. So yeah, 3 and 6. Good job. Chavez, what's the other pair, dude?
4 and 5.
4 and 5. Let's see. Opposite sides of the transversal, inside the parallel lines, congruent. Absolutely. 4 and 5. Those are alternate interior angles. Now that we know what that is, there's a question there on the bottom. Nolasco, can you read that for me?
If angle 1 measures 75 degrees, what is the measure of angle 2?
Okay, so let's keep that in mind. Are these alternate exterior angles, yes or no? And are alternate exterior angles congruent? Yes or no? So if this is 75 degrees, what is the measure of angle 8?
75.
75 degrees because they're alternate exterior angles and they are congruent. Good job. So it's 75 degrees because they are alternate exterior angles. If this is 75, that means that this is in fact 75 degrees. Everyone have that written in?
Yep.
Okay. Let's talk about another type of angles that are created here. These are known as corresponding angles. And you always have to go through the criteria for this. Corresponding angles lie on the same side of the transversal, and they are in the same position in relation to the parallel lines. What does that mean? That means that same sides, such as 2 and 6. They're both on the same side of the transversal, right?
Yes.
2 and 6. And they are both in the same position relative to the parallel lines. Look at angle 2. Is angle 2 above the parallel line, yes or no?
Yeah.
Yes. Is it to the right of the transversal?
Yeah.
Yes. Look at angle 6. Is angle 6 above its parallel line? Yes. Is it to the right of the transversal? Yes. These are corresponding angles, and just like alternate interior and alternate exterior, they are congruent, which means that if angle 2 measures 105 degrees, that angle 6 has to measure 105 degrees. So we know that 2 and 6 are corresponding. There's 3 more sets here. Let's go to Rachel Thomas. Give me another set of corresponding angles. 1 and 5. Let's see. Okay. 1 and 5. They're both on the left side of the transversal. Good. They're both above their respective parallel lines. Good. They are both acute angles, which means that they are congruent. 1 and 5 are correct. Ali, give me another set.
4 and 8.
4 and 8. Let's check out 4 and 8. 4 and 8 are both on the right side of the transversal. They're both below their respective parallel lines. They're both acute, which means that in this case they are congruent. So 4 and 8 works. There's only one set up there. Everybody should know this. What's the last set?
3, 7.
3 and 7. You can get there kind of by the process of elimination. Okay, 3 and 7. All right, now let's examine some questions here before we go to lunch. If angle 2 measures 105 degrees, we know the measure of angle 6. But the further question, the deeper question is, what is the measure of angle 1? Anybody have an idea what the measure of angle 1 is? I saw his hand go up first. So what do you got?
It's 75 degrees.
75 degrees is absolutely correct. Anybody care to venture why it's 75 degrees? Not enough for me just to write it up that you have to know why it's 75 degrees. Calco, he had his hand up first. Calco, why is it 75 degrees?
Because it has to, because the line has to be equal to 180, so you have to subtract 105 from 180 and it will give you 75 degrees.
Perfect. But how do you know that they're 180?
Because it's a straight.
Because, okay, that's one way to identify. Yeah, this is together they form a straight angle. That's 180 degrees. There's something else here as well. What do you got?
It's half a circle.
It's also half a circle. Both of those things equal 180 degrees. So together they're 180, and I know that this is 105. In order to find out what this is, I simply subtract 105, and I get 75 degrees. What you're going to find out is if you know the measure of just one of these angles, you actually know the measure of all of them. So angle 6 is, we already did that one, 105, because they are corresponding angles. And angle 1 is 75 degrees because it's a straight angle, or it's half a circle with angle 2. Any questions on that? Any questions? Alrighty, so back to the transversal. We still have more lines to talk about. We still have more angles. Still have more angles to talk about. The next set, same side, exterior angle. So same side of the transversal, they are exterior. They lie outside of the parallel lines, and unlike all the other angles we talked about so far, they're not congruent. What they are is supplementary. And supplementary is how many degrees?
180.
180 degrees. So when we say two angles are supplementary, we say that they are 180 degrees. So we're looking for same side exterior angles. So remember, same side of the transversal. So 2, 4, 6, and 8 all lie on one side of the transversal. 1, 3, 5, and 7 all lie on the other side of the transversal. They must be outside of the parallel lines, such as, if we go here, we can eliminate 3, 4, 5, and 6, because those are not inside the parallel lines. That leaves us with angles 1, 2, 7, and 8. Can you, Calco, give me a set of same side exterior angles, given that criteria?
1 and
1 and
7.
and 7, perfect. They're on the same side of the transversal, they're outside of the parallel lines, and together, if you think about it, there's an acute, there's an obtuse. Those two together, when you add them up, when we have a parallel line cut by a transversal, they would equal how many degrees? 180 degrees. They are supplementary. These two together, and 1 and 7, would equal 180 degrees. So 1 and 7. Corey, what's another pair of same side exterior angles? 2 and 8. What would they equal if we added them up?
180.
180 degrees. Just like 1 and 7. They would also be supplementary. They would equal 180 degrees. What you guys come to realize here is when you have parallel lines cut by a transversal, any set of acute and obtuse angle combinations equal 180. Doesn't matter if I add this acute and this obtuse, those will equal 180. 180. That's an obtuse, that's an acute. What do you think 4 and 6 equal? What do you think?
180.
180. What do you think 3 and 5 equal?
180.
180. There's the obtuse, there's the acute. Let's see. 1 is acute, 6 is obtuse. What do you think they equal together?
180.
180. So if you're combining the acute angle and the obtuse angle, they equal 180. Should you forget everything else, you can always fall back on that. Now, if we have same side exterior, we should also have same side interior angles. They also lie on opposite sides. They lie on the same side of the transversal, and they are on the inside of the parallel lines. They are also supplementary, which means they equal 180. Matthew, give me a set of same side interior angles.
3 and 5.
3 and 5, okay? So, same side, good. Inside the parallel lines, you have the obtuse, you have the acute. Together, they would have to equal
180.
180 degrees. Good. And, Connor, what's the last set of same side interior?
Same side interior. 4 and 6.
4 and 6. And if we add those together, Connor, what do they have to equal? 180 degrees. Any questions on same side angles? Exterior or interior? What's up? Okay. All right, an additional set of angles that are good to know are vertical angles. Now, vertical angles lie directly across from each other, and they are also congruent. So, let me give you an example of vertical angles here. Now, vertical angles, don't confuse those with adjacent angles. Adjacent angles are right next to. Vertical angles are directly across from. What that means is if I'm looking at angle 1, angles 2 and 3 are adjacent. It means they're right next to angle 1. Those are not vertical angles. What do you think the vertical angle to angle 1 is? Anybody know?
4.
4. Angle 1 and 4 are vertical angles. They lie directly across the intersection from each other. 1 and 4. That means that if I know that 1 is 70 degrees, then what is 4? 70 degrees. And here's how it all starts to fall into place. If 1 is 70 degrees, and think about this before you answer it. If 1 is 70 degrees, then together, what do 1 and 2 have to equal? 180. So what is the measure of 2? 110. 110 plus 70 would equal 180. So if I know that angle 2 is 110, the vertical angle to angle 2 is angle 3. What does angle 3 have to equal?
110.
110. And that should also make sense because if I add all 4 of these up, what should they equal?
360.
360. Let's say 110, that's 180, that's 290, that is 360 degrees, also known as a full circle. All right, so we'll write in 1 and 4 and 2 and 3. And let me clear this out because we don't really need this, it's just for the point. 1 and 2 and 2 and 3. If you guys drew that in, that's totally fine. I'll reconnect this. 1 and 4 and 2 and 3. And it's over here. So. All right, we have 2 more sets of vertical angles. Let's go to Fiona. What are the other set of vertical angles? 5 and 8. Good. They lie directly across the intersection from each other. Notice they're not next to each other. They lie across the intersection from each other. So 5 and 8, and what's the last ones? 6 and 7. 5 and 8, 6 and 7. 5 and 8, 6 and 7. Yes, Emily.
How would you like write a question for this? Like if you...
How do I write a question? I would say, okay, angle 2 is equal to 105 degrees. Give me the measure of angle 5. And you have to maybe do a little math here. You could say, okay, lots of different ways you could answer this. If angle 2 is 105, and together these form a 180, that means that this is 75, right? Angle 4. Well, angle 4 and angle 5 are alternate interior angles, and they are congruent. So it means that this is 75, this has to be 75. You see how that works? All those little rules come into play. If you know one of them, you actually know all of them. All right, let's actually go in and answer a couple other questions here. If angle 3 is, well, it should be pretty simple. If angle 3 measures 120 degrees, flash, angle 3, if this measured 120 degrees, what is the measure of angle 2? 130 degrees. Why? Because they are what? They're vertical angles. Good job. Ms. Gutierrez, I put a box around just this part of the line right here. What type of angle is that? It's a straight angle. How many degrees is a straight angle? 180 degrees. Good job. Any questions on this one? Any questions? No? You see how if you know one of them, all the rest of them start to fall into place? If you pick any single angle here, you actually, as soon as you're given one of them, you actually in effect know every single angle here. The main thing is to have to know how to justify why you got those answers. Anyone can write in random numbers, but you have to know the why. All right. Let's go in and let's just pick. Let me show you that this works. Now this, what type of angle is this?
Acute.
It's an acute angle. So I'm not going to say that this is going to be exact. What we're going to do is we're going to show you exactly how we get all of these angles here. So this is an acute angle. Dylan, give me an acceptable measure for an acute angle.
55 degrees.
55 degrees, okay. So if this is 55 degrees, that's an acute angle, right? That means that every other single acute angle here is how many degrees? 55 degrees. And that means that every single obtuse angle here would be, anybody? Did the math real quick?
110.
No, that would be 165. 125. This would have to be 125 because together they form a straight angle or half a circle, which means that together these two have to equal 180. And then we can just start getting the rest of the angles from there, depending on the rules you want to use. Do I know this angle right away?
Yeah.
What is it?
125.
125. Well, we can say that these are alternate exterior angles. And do I know this one?
125.
125 because they are what? Begins with a V. Vertical angles. And do I know? Do I know this one right here?
Yes.
What is it? 55. Why? Starts with a C. Not congruent, but what? Corresponding angles. These two are corresponding. And then you notice that we can just kind of go in and fill the rest of them here. This is 125. What would this be?
55.
55. If you add all four up, what should it equal?
360.
360 is a full circle. And then this is 55 degrees. You just have to know how to justify these things. Any questions on these? No? Okay. So after this, we'll move to the algebra side of it. So 4, 3, 2, 1 on this. The algebra side of it, which is as simple as you writing an equation and solving using the exact same information. If you can solve, I don't know, a two-step equation, then you're totally good here. Now, we know that given any of the angle measures, we can find all of the other angle measures. For example, if the measure of angle 6 is 110 degrees, then what is the measure of angle 3? Anybody got an idea? Shimon, what's the measure of angle 3, bud? You're saying that 6 is 110. What do you think the measure of angle 3 is? is also 110. Good job. Because they are alternate interior angles. Now, we can make a very quick jump and substitute algebraic expressions in. Now, these are still same side interior angles, right? We learned that a second ago. And same side interior angles are supplementary, which means they equal what? 180. And you could write the expression just like this. 6x plus 3x equals 180 because they are supplementary. How would you go ahead and solve this, Madison? What would you do to solve this equation? First thing you should do is 3 words. Combine like terms. You can combine these two, right? 6x plus 3x gives me 9x. We have 9x equals 180. And then we would divide both sides by the coefficient, which is 9. And that gives me x equals 9. Where's x equal? No. Divide 180 by 9. What's x equal? Anybody? 20. So x equals 20. But is that my answer to this question? No. It's asking me what is the measure of angle VWZ and the measure of angle YVW. So you now have to take 20 and substitute it into each expression. So for VWZ, that's this one right here, we have 3x, which means I'm basically just doing 3 times 20. What's 3 times 20? 60 degrees. And since they're supplementary, you could either do the multiplication or you could realize that together, these two angles have to equal what?
180.
180. So if this is 60, this has to be
120.
120. How can you check that? Substitute in 6x or 6 times 20. Yeah, that equals 120. You're writing a simple equation using the rules that you already know in order to solve for the missing measures. Let's see what happens when we take away the training wheels. Any questions on this slide? Yeah, what's up? Yeah. What's up? How did I get what? How did I get 9? I had 6x and 3x, right? So I knew that they were same side interior angles, and together they had to equal 180. So what I did is I wrote an equation. 6x angle YVW plus 3x angle VWZ equals 180. And I combined the 6 and the 9. 6 plus 3 equals 9. So I said 6 and 9. I combined the 6 and the 3 to get 9x. I divided out the coefficient. What's up?
After you get x equals 20, can you show me what you did?
After I got x equals 20, what I did is I went back to the original expression. So for VWZ, the expression was 3x, right? I know that x is 20. I know there's multiplication happening between the 3 and the x, so I did 3 times 20, and that gave me 60. For the other one, angle YVW, I know that the expression is 6x. So I substitute in the 20, or x. What's 6 times 20?
120.
120. That's how I got that. And that answer checks out because together they should equal 180. So the answer works. If you ever do something like that and you get something like 213 degrees, you know you did something wrong somewhere. Go back and figure it out. All right, let's try another one here. So now we have 4x and we have 6x. These two angles right here, GDE and BEF, are supplementary. What does that mean? How many degrees supplementary?
180.
180. So I can write an equation for this. Maldonado, what's my equation going to be?
What do you mean?
I can write an equation given this information. Together, they equal 180 degrees.
Okay,
You have two expressions, so we put them together. What would it be?
6x plus 4x equals 180.
Perfect. 6x, this angle, plus 4x, this angle right here. Together, they're supplementary, so that means they would equal what? 180 degrees. What is the next step here, Miss Vega? What's the next step? It's 3 words. We combine like terms. What are the like terms you can combine here? 6x and 4. So we put them together, what do they become? 10x. So 10x is equal to 180. I divide out the coefficient from both sides, and I get x is equal to 18. But is that my answer?
No.
No, I now have to go back and substitute this into each expression to find what the measure of this angle is and what the measure of this angle is. So I will deal with GDE first, angle GDE, that equaled 4x. So instead of 4x, I substitute in the 18. So, Sean, I'm going to take the 18, I substitute it in here. And instead of 4x, it's going to be 4 times what? 4 times 18. And what is 4 times 18? Well, let's do a smaller problem. What's 4 times 72? Good job. So that's going to give me 72 degrees. So GDE is 72 degrees. Let's go in, let's go find the BEF. What is the expression, Sean, for BEF? BEF. It's right there. What's that expression? Just the number. What is that right there? 6x. So you just write 6x. But we're going to substitute in the 18. You with me? That gives me 6 times 18. You know what 6 times 18 is? Well, let's do a simpler problem. What's 6 times 10? What's 6 times 8? Okay, and what's 60 plus 48? 180. And this answer, let's see if it checks out. We said they were supplementary. 72 and 108, is that going to give me 180?
Yes.
Yes, it is. So my answer is good. So this is 72 degrees. And that means that this is 108 degrees. Once again, we're going back to those same numbers, 180. If we put them all together, 360, put 2 of them together, 720, so on and so forth. What's up?
Where do you get the variables?
The variables are in the problem. Now this is what happens. If you knew that this was 72, what we're doing is we're starting to get you into geometric algebra. So we've taken away the degrees and replaced them with expressions. So gone is 72 degrees, right? If this was 72, and I asked you what this is, you would have been able to use one of the angle relationships and tell me it was 108, right? But instead, what we've done now is we removed the degrees and replaced it with variables. But since you know that these two are supplementary, you know that you can write an expression or an equation, set it equal to 180, solve it, and you can find out what the measure of each angle is. This is where we start combining geometry and algebra to make galgebra. It's not a real word. What's up?
When you don't have a supplementary angle, will you put the variables that it will be equal to what, 360?
There's always a way to find it. You simply have to identify the relationship. So if I were to say that this was, now just pay attention up, you don't have to write this down. If I were to say that this was 5x and this was 5x, the thing is, these are congruent. They're not supplementary, so you don't know what they are. But the problems that you would solve would have something like this. 5x, and this is 5x. Together, you know that these would have to equal 180. You could do 5x plus 5x equals 180 and solve it out from there, right? There you go. Any questions on this one? Questions? No? Remember, we're writing equations and we're solving. One more problem to go. Mr. Moda, we have TWV and we have SPW. You want to identify the relationship here. So we have these two angles. You know what those are? What relationship they have?
It's
You know what they're equal?
they both would equal 180.
They equal 180. They're same side interior angles. So that means they're supplementary. That means that together, these would equal 180. And all you're doing now, I know we've introduced one little thing here, you're still just writing all these terms out, and you're setting it equal to what number?
To equal 180.
180. Shimon, tell me, what's the left side of the equation going to look like, bud? What's the first expression? 3x minus 5. What's the second expression? Is that a positive or negative 2x? So what symbol should separate these two terms? What symbol should separate it? It's a positive 2x. What symbol indicates positive? No. Symbol. What symbol? Multiplication, division, subtraction, addition? Which one? Alright guys, if it's a positive number, what symbol do we use?
Addition.
Addition. It's a positive number. That's addition. Shimon, combine your terms here. 3x and 2x. What would they equal? 3 plus 2, 5. Alright, so we combine these. That gives me 5x. I bring down the negative 5. That equals 180. How would I go about solving this, Chris? This is a two-step equation. 5x minus 5 equals 180. How would I solve that equation? What happened? No, not dividing yet. In order to divide, you have to get the x term alone by itself. How do you get the x term alone by itself? What happened? You need to get the x term alone by itself. So what's the opposite of a negative 5? Yeah, you add 5 to both sides, but plus 5 plus 5. That's going to give me 5x is equal to 185. Hey, Jerome, do you have a question? Okay. Now that we're here, we divide both sides by my coefficient, which is 5 and 5, and I get x is equal to, anybody?
37.
37. X equals 37. Is that my answer, though?
No.
No, I have to substitute it back into these two expressions, which I will do now. The first expression is 3x minus 5. So 3x minus 5 becomes 3 times 37 minus 5. And anybody know what's 3 times 37? 111 minus 5 then gives me 106. So I know that TWV is 106. That means SVW has to be what? Without even doing the math. 74 degrees. Because together they have to equal 180. In case you want to check that, just do 2x, 2 times 37, yeah, it still gives me 74 degrees. Any questions? Any questions on that? No? Very good, very good. Well, when you're done with the whiteboard? What? When you're done with your whiteboard? Like always? Yeah. Yeah. Alright, so 4, 3,